This is a demonstration of the text network analysis and keywording context applications that use political text data from the Finnish parliament. The DNA app uses plenary speeches from 2018 and 2019, while the KWIC app covers the period from 1990 to 2022. For the purpose of this demonstration, we have two separate Shiny applications that use the same raw data but have differences in how the data is processed and retrieved in the app. The main challenge these applications tackle is the sheer amount of available data, in this case hundreds of thousands of documents. Of course, it is possible to perform a qualitative analysis on a limited number of parliamentary documents, but once the time frame expands and the number of speakers increases, human capacity quickly falls short. And this goes to the heart of digital social sciences. The text network visualizations and the keywording context tools the apps offer provide intuitive and easy-to-grasp instruments to analyze the trends and features of interest in a large text dataset. Starting with the text network analysis app. The user can select the MP from the drop-down box on the left-hand side by either clicking or typing the speaker's name. First, the app lists the 10 most similar and least similar speakers measured on word-based cousin similarity. The higher the count between 0 and 1, the closer the speakers are to each other. This already gives us a sense of the semantic networks of speakers. Consider the party affiliation. We can expect the speakers from the same parties to be quite close to each other, but with this mechanism, we can also notice some surprising similarities and outliers. On the main panel, the app provides three different visualization options. First, the timeline shows the number of plenary speeches given by the selected speaker. This enables us to take the first steps in analyzing the speaker profile of the selected MP by providing a measurement of their activity on the floor. The volume and spikes of talkativeness can be observed at a glance, allowing a straightforward temporal comparison between different points of time and speakers. Suppose a user wants to know how an election has affected the speech activity in the parliament. With a few clicks, they can now simply view the timelines of the speakers of their choice and compare the results. Next, the word cloud collects the most frequently used words by the speaker. While the timeline gives us an idea of when and how much a certain speaker spoke, the word cloud tells us what exactly they spoke about. What kind of issues were they interested in? What were the dominating themes of their speech? This can serve as a valuable starting point for thematic and topical analysis, among other possibilities, but also as a powerful illustration resource. Finally, the concept network visualizes the connections between 10 most similar speakers to the selected speaker and words that are commonly used by them. Given that speech is political activity and word choices are political choices, modeling the connections between speakers through concepts opens the door to examining ideological similarities and semantic patterns that might otherwise be difficult to detect. We can ask questions such as what kinds of linguistic choices unite and differentiate certain speakers, and what sort of speech they generate. Moving on to the second deliverable. The KWIC or the Keyword in Context application provides tools for analyzing the relationships between concepts. While in the DNA app the main focus is on the speaker, here the central point of interest are the words themselves. First, the KWIC tool displays the instances where search term appears in the speech data. It returns the words that appear in the documents before and after the search term, and by clicking the row, the user can view the speech in question. The n-grams, in turn, reveal the sequences of words that are often used by the MPs. The user can also enter an additional search term to view contexts where both terms appear. Below the Word Co-occurrence tab, the app displays the collocations of words that are often found together with the search term. Finally, the collocation network visualizes the keyword embeddings as text networks. The user can change a number of settings, for example, the thresholds for the collocation strength and the minimum term frequency with the widgets in the upper right corner. As in the DNA app, the tools provided in the KWIC application enable discovering trends and regularities in the plenary speech data that might be virtually impossible to find by close reading only. For example, a researcher, a student, or say a journalist might be interested in finding out how controversial or ambiguous terms like racism, equality, or welfare have been discussed and framed by the MPs. How has the discourse changed over time, and what other themes have been associated with these concepts? Instead of going through an endless number of parliamentary documents one by one, the KWIC tools can be utilized as a starting point for research, as well as a method for the analysis itself. As new research infrastructure resources, the DNA and KWIC applications provide user-friendly data analysis tools not only for researchers and students, but crucially for the wider audience as well. By collecting Finnish parliamentary speech data and offering an easy way to explore it, these deliverables contribute to the transparency and accessibility of political information and to the popularization of social sciences and humanities research.